Okay, so you're squaring a binomial, correct? And so remember, go off to the side and kind of figure out what that is. So I'm going to go to the next page. Just do this on the next page. So really, this x minus 2 squared means x minus 2 times itself. So what do you think is going to be the next thing you're going to do? Well, it's already factored. What are you going to think you're going to do now? FOIL it out. You're going to multiply it out. So FOIL. So x times x is x squared. The outer. Now notice, see how you have a binomial times itself. These two binomials are the same. So the outer and the inner should be what? The same, right? So the outer's negative 2x and the inner's also negative 2x. And then the last, a negative 2 times a negative 2 is a positive 4. Combine like terms, I get x squared minus 4x plus 4. And so that goes here. So that's x squared minus 4x plus 4. Okay? So I'm going to go ahead and remove this page. And so notice I went from a radical equation. Over here I went from a radical equation to what kind of equation? Here, right here. Linear. So that was linear. Here I'm going from radical equation to what kind of equation? Quadratic. So that's quadratic. So how do you solve a quadratic equation? Yeah, so you're gonna put in standard form. Now normally what happens for those, for ours, it will be factorable. So just say equals 0. You can use a quadratic form if you want to. If you can't figure out how to factor it. Now sometimes it can be factored, but the ones I think you're gonna have will be factorable. The ones in my math lab are factorable. So just bring everything to one side. So I'm going to subtract x first. And then x minus x is 0. And you're left with what on this side, the left side? 10. Over here, when I combine like terms, I get x squared. A negative 4x and a negative x is a negative 5x plus 4. And then what's the next step? Subtract 10. Notice I'm aligning my like terms. So I align the x's together. Now I'm aligning the constants together. 10 minus 10 is 0 equal x squared minus 5x. A positive 4 and a negative 10 is a negative 6. Okay, now I'm just going to go ahead and transpose the sides. So 0 equals this is the same thing as this equals 0. I'm just going to go ahead and rewrite it like this. Okay, so what's the next step? Factor. If you don't remember how to factor this, you use quadratic formula. If you use a quadratic formula, what's A? What's B? Negative 5. What's C? Negative 6. Okay, but I can factor this. X times x is x squared, right? The last sign is negative, so that means these signs in here are going to be different. And what are the possibilities for 6? There's 6 times 1 and 3 times 2. Which one do you think you'll use? 6 times 1. 3 times 2 is not going to work. But 6 times 1 will. So 6, 1. Remember, 1 has to be positive, 1 has to be negative. Now remember, you want the middle sign to be what kind of number? Negative. So if you look at the outer is 1 times x, which is x. And I'm sorry, the outer is x, and the inner is what? 6x? The larger of these, you can't see it, but that's a 6x right here. The larger of these takes the middle sign, so which one should be negative? 6x. And check yourself, is negative 6 and a positive 1 and negative 5? Is negative 6 and a positive 1? And, yeah. All right, so I need 6x to be negative. So that means this right here has to be what symbol? Subtraction or addition? Subtraction. Subtraction. And this has to be addition. All right, so we factored it.
When you use that staff where you got it in the standard form with the 0, how do you know which method to use?
What do you mean?
So you know to factor that out? I mean,
what's a quadratic? So you only know several ways of solving a quadratic equation.
right.
Factoring, completing the square, quadratic formula.
Why couldn't you use quadratic formula?
I said you could. I didn't say you can't. I said you could, but it can be factored.
Okay, how do you know it's easier to factor? What makes you think it's easier?
Experience. Not everything. That could have been x squared minus 3x, minus 5x minus 7. In that case, you couldn't factor it. Just looking at it, you can tell it's not factorable. So it's probably because you hadn't had enough experience with factoring to see this. So if you try something and it takes you 2 minutes, you still can't figure it out, then give it up.
And
Go
do
to the
that
quadratic
right.
formula.
That's what, okay, because I can
Okay.
this.
All right, but you really need to know how to factor.
Oh, I got factor. I just don't know, when I look at that, now that I know different ways of doing it.
Yeah.
I don't know which ways could be the best, you know?
It depends on what you remember. Now, these are factorable.
Okay.
Now, there are some situations where it's not factorable. So you had some we solved quadratic equations in one of the worksheets you have to turn in next class period on section 1.5. There's some quadratic equation where it says use a quadratic formula.
Right. Yeah.
Well, those could not have been factored. You get the square root, right? When some of them the square root, well, that if you get a square root as part of the answer, it's not factorable. So if you tried factoring, you couldn't. So you give it up after 5 minutes and then realize maybe I can't factor this, and I just use the quadratic formula. Okay? But whenever you have the only ones that are factorable for, let me rephrase it, from section 1.5 where you had to solve quadratic equations were the ones that had rational solutions.
Right, and if the coefficient's not 1 in like A, in the standard form, then I would want to factor it. Because I find it harder to, like, say it was, I don't know,
Well,
4 squared.
Okay, 4x squared?
Yeah, 4x
Okay.
squared.
What about it?
It just, I don't know. To me, I think whenever the first,
X squared.
right.
What about it?
If the coefficient's x, just 1.
If the equation's 1, that's the easiest one to do.
Yeah.
That's in fact that's the first one you talked about last semester.
Right.
And
So
that every student can get that. It's when it's not when it's 2 or 3 where they have a little trouble with the reverse FOIL.
Right.
But not everyone can be factored. So keep that in mind because some of them are prime. Okay, what's the next step? Come on now. You've already done section 1.5. This part right here, guys, is section 1.5 right here. What the zero factor property. Okay, that was section 1.5. You had a worksheet due on that. So that part's 1.5. This part's 1.6. The rest of this is 1.5. Okay, so see zero factor property says set each one equal to 0. So each factor equals 0. And notice I went from a radical to a quadratic to 2 linear. All right, so what's the next step? X is what? 6, and X is what? -1. All right, now you got to remember. So remember, step 1 was to get a radical by itself. Step 2 was to raise both sides to a power equal to the index. Step 3 is to solve for the variable. Now, step 4. Remember, what was when you raise both sides to an even power? What could happen? You remember? No. There aren't any restrictions here, so to speak. Extraneous solutions. When you raise both sides to even power, you could introduce false solutions. So remember the word extraneous? So in other words, if you plug in 6, does 6 work? So you have to check your solutions. So step 4 is you check your solutions. You have to. Now the only time you check it is if you raise both sides to even power. Did I raise both sides to even power? Did I? No one's answering.
Yes, you did.
Yes, you did.
Yeah.
Squared. I raised both sides to even power, so I have to check. So if you always have to go back to the original problem, the one with the square root. So let's check for extraneous roots. So the original was the square root of x plus 10 equal x minus 2. So let's check x equal 6. All right, so wherever see an x, I plug in 6. So I get the square root of 6 plus 10. And I want to see if that's going to equal 6 minus 2. What's 6 plus 10?
16.
What's the square root of 16?
4.
Okay, what's 6 minus 2? And they are equal, right? So 6 works. All right, let's check x equal, what was the other one, -1? All right, so go back to your original. X plus 10 equal x minus 2. So in place of x, I plug in -1. I get the square root of -1 plus 10 equal. I want to see if that's equal to -1 minus 2. What's -1 plus 10? What's the square root of 9? Okay. What's -1 and -2? Are those equal? No, not equal. So x equal -1 is an extraneous root. So it's a false solution. So usually what happens is students tend to forget to check when they have a radical equation. They tend to forget to check for extraneous roots. So they'll eventually say, they'll get all this right and they'll say these are the solutions. These two are the solutions, when actually it's not true. Which one is the only solution? X equals 6. Right? So remember, it's extraneous roots. It's a false solution. Now, what that meant was that -1 satisfies this quadratic equation. Because what's the -1 squared? If I plug in -1, +1. What's a -5 times a +1? +5. -5 times a -1 is a +5. 1 plus 5 is 6. 6 minus 6 is 0. So it is a solution to this, but is it a solution to the original equation? The answer is no. Okay? All right, so then the answer in the blank, you'd say x equal blank. What would you put in the blank? 6 only. Okay? All right, and then let's do one more with radical. Just make sure you go back and look at those videos with the radical. Okay, so let's look at number, this will be number 16. So it'll be the square root of 6x plus 1 plus 1 equal x. So the square root of 6x plus 1 plus 1 equal x. All right, so it's the first step. What is it you got to do? Yes, you got to get the square root by itself. So you subtract 1. And so I get the square root of 6x plus 1 equal x minus 1, right? Okay, so then what's the next step? Square both sides. All right, and then what's going to be on the left side? 6x plus 1 only. Okay, now I got to do some work here, right? Because I'm squaring a binomial. So that means x minus 1 times itself, correct? So what did you got to do now with this? No, it's already factored. Okay, multiply it out. So using the fold method, x times x is x squared. What's the outer? All right, and the inner should be the same thing, right? And what's the last? Combine like terms, what do I get? X squared minus 2x plus 1, correct? Okay, that goes here. X squared minus 2x plus 1. All right, so I went from a radical equation to what kind of equation? So how are you going to solve this quadratic equation? What do you have to do? Right, so you're going to put in standard form, correct? You're going to say minus 6x minus 6x. I'm aligning my like terms. So combining like terms, 6x minus 6x is 0. What's 0 plus 1? 1 equal x squared. What's a negative 2x and negative 6x? 1 plus 1. What's the next step? All right, subtract 1. 1 minus 1 is 0. Equal x squared minus 8x, right? And that's 0. Okay, so I have this quadratic equation in standard form. What's the best way of solving this? No. Completing the square is always going to be the more tedious one. Factor. How can you factor this? All right, very good. So remember, the first thing you need to do when factoring always is look for GCF. So do these two terms have something in common? Yeah, they have an x. So you get 0 equal x times what? X minus a. Right? So you factored. So in the previous one, you had a trinomial. See this? You had a trinomial. So you have to use right here. So you have to use the two binomials and use the idea of FOIL. Here, that's just two terms. So and the GCF is just x. You take out the x. Now, how many things are being multiplied together? How many factors? 2. So I'm underlined them. Now, what do I do to those two factors? Zero factor property. Set each one equal to 0. So I get x equals 0, and what's the other one? X minus 8 equals 0, which means x equal what? 8. So how many? So what are your proposed solutions?
0 and 8.
0 and 8. All right. But remember, I raised both sides to what power?
2.
Which is an even power, so I have to check. I have to check for extraneous roots. Okay? All right, now always go back to the original. Go back to the original. So we're going to check for extraneous roots or extraneous solutions. All right, so let's do x equals 0. So I'm going to just rewrite the previous one, or the original one. So the square root of 6x plus 1 equal x. So in place of x, what do I plug in? 0. All right, so we got the square root of 6 times 0, right? Plus 1, and I want to see that's going to equal x, and what's x? 0. What's 6 times 0? 0 plus 1?
1.
Okay, square root of 1 plus another 1? 2, right? And is that equal to 0? No. So x equals 0 it's a solution to this quadratic one right here, but is it a solution to the original? No. So remember that's your extraneous root right here. All right, so I can't use it. Now what about 8? Let's check 8. All right, so get the square root of 6x plus 1 equal x. Square root of 6 times x is 8, plus 1, and we'll see that's going to equal x, and x again is 8. See, all I did was just, wherever I saw an x, I just plugged in 8. What's 6 times 8? 48. 48 plus 1 is? All right, and then plus 1. What's the square root of 49? And is 7 plus 1 equal to an 8? Yeah. So the answer will be x equal what? X equal 8 only. Okay? All right, so that's the radical. You just got to practice this, and remember, it's all mixed up on the test. You saw many kinds of equations where you solve radical equations, you solve quadratic equations, you solve linear equations. Yeah, and now you're about to solve absolute value equations. So they're all mixed up. So the best way to remember what to do in each one is to actually do the problems over and over. Mix them up. On an index card, write the problem out and see if you can remember what approach to take for each one. But they're all mixed up. All right, so remember, when you have radical equations, what do I do? When I have a quadratic equation, what do I do? Now, a good thing with these is because in here you end up having a what? Quadratic equation. So it's kind of mixed up anyway. So it kind of helps knowing what to do in each of these situations. All right. Okay, let's look at this. All right, so that takes care of the radical equations. All right, so I've done 3 problems of those. I did 1 last class period. I did 2 today. So just go back and look at those. Look at them again, and then just go to the videos. There's some more in some videos with those. All right.